Okay, assalamu alaikum. I got a DC motor जो मुझे कहीं से मिल गया. I thought it will be good to show you some stuff inside, what is inside the DC motor. So let's do the unboxing. Okay. I opened up finally this motor, and you can see the first thing here that we have our carbon brushes connected, and let's see, the first thing that we should see is the commutator, right? Yeah, that is our commutator. So let's get this out as well, and we'll see that we'll see the close-up of that one. Now everything is apart, so let me show you the stator. I hope you can see. So you can see the two permanent magnets there, which are in curved pole faces shape. So this is just to maintain that the air gap is fixed throughout the 360-degree rotation. So that's our stator part. But if you have a self-excited machine, that stator part will be also wound with the field windings. Okay, so let's see the rotor part. The rotor has the shaft, which is, this goes like that, and we have the commutator segments there, and उसके बाद then we have the windings which are wound around the rotor. So let's see how many commutator segments are there. It's very difficult to count, but it can be counted. Okay, so you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 9, 10, 11, 12. So there are 12 commutator segments there. So maybe you can pause the video here and just count the number of commutator segments. Okay, so let's see how many slots are there. So let's pick a point from where we can. So there's this mark here. So we can start from this point. That this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is according to what we studied, that there will be the same number of commutator segments as there are the slots, or as there are the number of windings. So there are 12 set of windings as well, and you can see this is a 2-layer winding. So each slot is 2 winding layers inside that, right? So 1 and 2. So you have 2. This is a 2-layer winding, right? And let's see what type of winding this is. Is this a lap winding or wave winding? So let's see that. Okay, in order to see the winding type, that it is either the lap winding or wave winding, then we can, let's see. So this is the end of the winding. This goes into this is a coil. This goes round, and this comes back from. So this, so this is the start, one terminal that goes into that, and this goes along these 2 slots, and this second end comes from on this one, on this commutator segment. So first end on this one, second end on this one. It means this is a lap winding. So if it was a wave winding, this should have gone around and to some other commutator segment and the second coil in series, and then it should come back over here, right? So then it was wave winding. But as this is the first terminal, goes around and then comes right after the second in the adjacent commutator segment. So it means this is a lap winding here. There's one really interesting thing here, which is this part. Let me see if you can see that. This is this part. what is that and why is it there, right? So it's this is a very interesting stuff. So the point is, when you study the problem of circulating currents in the machine, then you'll see why this thing is aided into the shaft, right? So this is essentially the good point for someone who is studying that, who is taking that case study. Let's see the carbon brushes. So these are the carbon brushes which press against the commutator segment. So these are like they are spring loaded. So these are spring loaded. So if you press, yes, so if you press those, that this, you can see the spring behind. So your shaft goes right between these two carbon brushes, and these brushes slide on the commutator segments. Okay, so that was our DC motor, unboxing of the DC motor.